It's the last topic for linear differential equation, that is a simultaneous linear differential equation. After the last lecture, we just mentioned about the solution of a single differential equation. Here we introduce the concept to solve a simultaneous. Simultaneous means more than one linear differential equation. It's the structure, it's the form of a simultaneous differential equation. Here we mention the form. This chapter we will discuss the differential equation which have one independent variable and two or more than two dependent variable. And to solve each equation completely, there must be as many equation are there are dependent variable. Okay, so here we consider the two linear differential equation. One is f1d, it's represent d is the f1 is the function of capital D. Here D stand for ddt. If we consider t is the independent variable and x and y are the dependent variable, in that case f1d represent ddt, f2d also represent ddt, x y, and this one is g1 dx plus g2 dy equals to dt. The above two equation represent the simultaneous linear differential equation. Here it is the number of equation is more than one, so it's a simultaneous equation. It's an example to realize this model. Dx dt minus 7x plus y. Here t is the independent variable and x is the dependent variable. T is the independent variable, y is the dependent variable. Here we consider the two differential equation, linear differential equation. You have to solve these two linear differential equation. When we solve a linear differential equation, solution should be a parametric representation of a curve. Okay, so this one, and the question is that how can I say it's the form of exactly in that form. If we write here, we mention the solution technique. If we write d stand for ddt, if we write d stand for ddt, you should not concentrate in this topic. You should not concentrate in this line. After this line, we make it clear for you. Should not concentrate in this line. It's the first method, second method. After completion of this method, we'll introduce another method. So you just concentrate to solve a linear differential equation. How can I write this differential equation in that form, the given form? So if we write this one is this one is 7x minus this dx dt. If we write ddt, d stand for ddt, then this equation becomes dx minus 7x plus y, and you can easily write d minus 7x plus y, d minus 7x plus y. Okay, and for the second part, you can write here dy minus 2x minus 5y equals to 0. This is minus 2x plus d minus 5y equals to 0. Okay, so this becomes your simultaneous linear differential equation. Here we mention the concept of method 1. Here we can solve a simultaneous differential equation in two different methods. Here we introduce the first method. Okay, the method is eliminating operator. Eliminating operator, that means here if we can eliminate the x, method of elimination, use of operator d. If you can eliminate this x, say you can also eliminate y. Here if we can eliminate x from these two equations, what should be happen? If you are in 9-10 standard student, you just solve 2x plus 3y equals to 5 and 3x plus 7y equals to 10. So many different method you study in your 9-10 level. Substitution, method of substitution, elimination, cross multiplication. If we use this substitution method, that means you can substitute a particular value of x from the first equation and substitute the value of x in the second equation. You can easily find only containing the variable y, and that you can solve to find the value of y. After putting the value of y in first equation, you got the value of x, and that should be the solution of x and y. When we consider in the simultaneous linear equation, not the differential equation, in that case you just multiplied some quantity in both the equation and eliminating some variable, and the remaining equation becomes a single variable equation, and you can easily solve this single variable equation and got the value of this variable. Put this value of this variable in the other equation, you got the another value of the variable, another variable value. Here we use the same procedure, okay, but here we not mention the multiplication norms, it's the operation norms, because d is your operator, so you cannot multiply a quantity by you can multiply a constant with a operator, but you cannot multiply a operator with another operator. So in that case we use the term operating. So if you can delete or eliminate x from these two equations, what should be the suitable case? If we multiply 2 with first equation and operate d minus 7 with the second equation, and add these two equations, we got a new equation which consists only y. So here we use this concept, multiplying 1 by 2 and operating 2 by d minus 7, we get this becomes 2 d minus 7x 2y equals to 0, and this becomes minus 2 d minus 7x d minus 7 into d minus 5y equals to 0. If you add these two quantity, x should be cancelled out from these two equation, and the remaining equation becomes d minus 5 into d minus 7 plus 2y equals to 0. After calculation, it's become d square minus 12d plus 35 plus 2, that should be 37. So now it's become a linear equation with constant coefficient. Here you consider the auxiliary equation. The auxiliary equation you can find replacing d by m, nothing more. So if we replace d by m, the result becomes m square minus 2m plus 37 equals to 0. So m becomes 6 plus minus I. After using Shridharacharya, the result becomes m plus minus 6 plus minus I. So the complete so the solution becomes y equals to, the norm says if the root is alpha plus minus I beta, in that case the solution or the complementary function, here the complementary function is itself is the solution, because the right hand side is 0. So the solution becomes e to the power alpha t, that is 6t plus c1 cos ct plus c2 sin t, because here beta is 1, so this one is c1 cos t plus c2 sin t, and c1 c2 are two arbitrary constant. If we put this value of y in any equation, you can easily find the value of x. So from this from equation number 2, if we consider this one is your second equation, so x becomes d minus 5 by 2y. So if we put the value of y in second equation, here we consider the next case is, if we put the value of y in second equation, from second equation we find x equals to half d minus 5 y. If we put this value of y here, so it's become dy minus 5y. That means you have to differentiate e to the power 60 c1 cos t plus c2 sin t. Here is the result, here is the result, again we mention here is the result, here is the result, okay. The differentiation of y, that means e to the power 60, when you differentiate e to the power 60, the result becomes 6 e to the power 60 c1 cos t plus c2 sin t. When we unchange e to the power 60 and differentiate c1 cos t c2 sin t, it's becomes c1 cos t becomes minus c1 sin t, and c2 sin t becomes c2 cos t. okay, and minus 5y, this one is the result. After calculation of all the thing, you just take a common e to the power 6t from here. After calculation, the result becomes this. That means here we write the cos t term in a single part and sin t term in the another part. That should be the value of x. That means what should be the solution of this simultaneous equation, which is the parametric form? The parametric form becomes this one: x equals to this, x equals to e to the power 6 t by 2 c1 plus c2 c1 plus c2 cos t, c1 plus c2 cos t, and c2 minus c1 sin t, and y becomes this one, exactly this one. Y becomes exactly this. That should be the solution. That means when we find the curve from a simultaneous linear differential equation, in that case we find the curve in the parametric representation. Okay, we find the curve in the parametric representation. So we take another example. You can solve this problem also. In the next class we will discuss this problem clearly. We start our next class exactly from this problem. It's another problem where the right hand side should consist something. Okay, so wait for the next lecture, because the boundary of this video lecture is 15 minutes. For that's why we should not continue this lecture, because I cannot complete this lecture within 3 or 4 minutes. So that should be the another lecture.